In this video, you will learn more about SQL Server indexes, one of the most important aspects of any database. But before we dive in, make sure to click on that subscribe button. It helps the channel to grow and allows me to create even more interesting content for you. Now let's get started. In SQL Server there are different types of indexes, but in this video we will focus on two main ones, clustered and non-clustered indexes. Basically, indexes speed up database queries, making data retrieval much faster and more efficient. Think of it like this. Imagine you have a huge table filled with information and you need to find something specific. How would you do it? Let's compare it to a book. If you want to quickly find specific information in a book with hundreds of pages, you wouldn't flip through every page. You would go straight to index, at the back, and find the exact page number instantly. That's exactly how indexes work in a database. They organize data efficiently, helping you to retrieve the information you need much faster. Now let's open SQL Server Management Studio and practice. We will see how indexes work, how to create them, and how to use them as efficiently as possible. Alright, let's connect to our database and let's start talking about clustered index. This is one of the most important performance features in SQL Server, as we said previously. A clustered index is what actually determines the physical order of the row in your table. You can think of it like sorting the page of a book. Once it's sorted, it stays that way. For example, when you create clustered index, the data itself is reorganized and stored based on that index. And because of that, you can only have one clustered index per table, just like you can only sort a book by one topic at a time. So let's check this clustered index. Go on and open your AdventureWorks database. This is our testing database, right? Go on and open tables. And let's choose one of the tables. For example, this table. And from here, as you can see, we have multiple columns. And also, let's check indexes. As you can see, we have only one clustered index. We have multiple non-clustered indexes, but we have only one clustered index. And if you open this one clustered index by clicking properties, as you can see, we have this clustered index on business entity ID. So my table person.person is sorted by business entity ID. Now let's check how this actually works. Let's select from our table. Let's click on new query. Let's write select star from this person.person. Okay, let's execute. And as we previously said, this is sorted by business entity ID. And let's write here where business entity ID equals to, for example, 111. We have this row, but let's see what happens on the background. To check what is happening on the background while you are running this query, go on and click on this button. This includes actual execution plan. Click on it. And after clicking on it, you will have this white box here and click on execute once again. And here, instead of only having result and messages, you will also have this execution plan. So from here, you will see that when this select statement executed, it used clustered index seek. So basically, there are three options: seek, scan, and lookup. Seek is the best way. It is the fastest way to find some row in a table. So if it says seek, then it is running good. For example, it said clustered index seek, right? So basically it used this clustered index where my column business entity ID is used, right? So now let's create our database and let's create our table where we'll be creating our clustered index. Let's write create database. Let's say again test. Go on and switch your database from here and create table. Create table, for example, test clustered, right? Let's say we have ID column here also, which is int, which is primary key, and not null, right? let's say first name varchar 50. Let's copy paste this one and say last name. And this is enough for this test environment. So let's create this table. Let's refresh our databases. As we already know, we need to refresh our objects when we create new ones. Go on and open test database, and we have our test cluster table here. So basically, when I created this table, I haven't included anything like create index or something like that in my script, right? I only included primary key here. So basically, when you create primary key, it automatically creates your clustered index on that key. Let's check the properties of this clustered index. And as you can see, my ID is used here. Let's again insert something. Values. Let's say 100. Let's say name brain wheel. And let's say in last name subscribe. If you haven't subscribed to my channel yet, go on and click that subscribe button. So let's execute this one. Let's say here once more 600. Let's say not 600, let's say 200. And let's select something from our table. Select star from our test cluster table where our ID equals to 100. Let's turn on our execution plan and let's select this. And as you can see, it used my clustered index. So as I said, we can create only one clustered index, but there is a case when you can create one clustered index and you can create multiple columns in this one clustered index. For example, for now, I have this one column ID here, right? But now I cannot add anything here. So basically you can create clustered index where you will be able to like add multiple columns. If you create like clustered index, for example, let's create another table, create table, again, test mult class. And let's say we have, for example, first name, $15, and we have like last name. Let's create this table. And as you can see, we have only columns and we do not have any indexes. So if you create a clustered index on last name and first name, then SQL Server sorts the table by by last name, and within each last name, it's sorted by first name. For example, let's go on and create new index. Click on clustered index. And let's add here, for example, last name, first one, and let's add another one, first name. So basically it will sort data firstly with the last name, and within each last name it sorts by first name. Click OK, and you will have your clustered index with 2 columns. So even though there is only one clustered index, you can still define multiple level sorting rule. This is super useful when your queries often filter or sort using multiple columns together. And just to recap, if your table doesn't have clustered index at all, it is calling a heap, which is basically an unordered pile of data and much slower to search. For example, if you do not have any indexes on your table, it will start gathering information from the heap and it will slow your database down. So in short, clustered index equals sorting storage, only one per table. but you can use multiple columns to define how it is sorted. So this is it for clustered index. And now let's talk about non-clustered index. Another super useful performance feature in SQL Server. But unlike a clustered index, a non-clustered index does not affect the physical order of the table. Instead, it is a separate structure that acts like a map or a shortcut to quickly find the data you are looking for. Think of it like an index at the back of the textbook. It doesn't change how the book is written, unlike the clustered index, but it helps you to jump straight on the right page. A non-clustered index stores the indexed columns values along with pointers to the actual row in the table, either using the clustered key or a row location if the table is a heap. The cool thing is, unlike clustered index, you can have multiple non-clustered indexes on a table, so if you often filter or search by different columns, non-clustered indexes are perfect for that. For example, let's again open our AdventureWorks database. Let's check one of the tables, and after that we can create our own. So let's scroll down and, for example, again use this table. You can see that we have multiple columns here and we have multiple indexes. We have this one clustered index again with one column, and we have like this multiple non-clustered indexes. Let's open properties of these non-clustered indexes, and as we can see here we have multiple columns in our non-clustered index. For example, last name, first name, and middle name. Let's select from this table and trick SQL Server to use these indexes to give us information. For example, where we have like our first name, or let's say our last name equals to what? Equals to this one. Let's turn on again our execution plan. Click on execute. And as you can see, it used our clustered index and also it used our non-clustered index. So basically it used both of them when we are selecting this data. So this is good. It says key lookup and key index scan. It is all right. So now let's again create our table with multiple columns. Let's create table. For example, let's create table in our test database again, for example, test, and let's call it, for example, something like non-clustered test, right? And after that, let's use different columns. For example, ID int, which is a primary key. After that, let's say again first name, which is nvarchar 50. In previous tables I used varchar. If you don't know difference between nvarchar and varchar, I have a separate video about SQL Server data types, and you can watch that video to know more about SQL Server data types. So for now, to tell you the difference, nvarchar is used for Unicode and varchar is used for like only English language alphabet. So let's say last name again here. Again, nvarchar 50. And I think this is enough. Let's create this table. And previously you saw that when I created non-clustered index, I used SQL GUI. So basically you can do same thing with this non-clustered index. You can use GUI here. Click on new index and click on non-clustered index. But let's script it and create with a script. For example, it is very easy. Create non-clustered index. Let's call it something, for example, ix non-cla, and let's use, for example, on what? On my non-clustered test table, and on which column? For example, let's say on last name. This is very easy. Let's run this script And let's refresh our indexes. As you can see, I have this index which I just created. So I do not have here any data, but still I can trick SQL to use this non-clustered index while I'm selecting. For example, let's select our last name. This is our non-clustered column, right? Let's select last name from which table? From this table. And let's say we are, for example, this last name equals to this brain wheel. Turn on your execution plan and run this query. As you can see, I do not have any output because I do not have anything in this table. Let's say our execution plan, and as you see, index seek non-clustered index. So basically my SQL Server used my newly created non-clustered index to search for the data which doesn't exist, but it needs to search it, right? So as we said, we can create multiple non-clustered indexes. Let's create another index with a GUI. Let's create new index, non-clustered index. Let's add, for example, we used last name. Let's add first name here and click OK. As easy as it is. All right, let's wrap up. We covered what clustered and non-clustered indexes are, how they work, and why they are so important for SQL Server performance. Just remember, indexes are all about making data retrieval faster, but they come with a trade-off when it comes to the data modifications. Use them wisely, test your queries, and design based on how your data is actually used. If you found this video helpful, give a like, and don't forget to subscribe for more SQL tips and database breakdowns. Thanks for watching, and see you in the next one.